Good evening and welcome to TR Physics, and today I'm going to talk about the NZ graph. Now, the NZ graph is a graph that is representing the relationship between amount of neutrons and protons an element has and how stable it is. Now, it's important to know a few things before we go on to this graph about the idea of the periodic table. Now, the periodic table shows you the stable form of the element. So if you see carbon 12, carbon is stable when it has its atomic mass number is 12, so it has 6 protons and 6 neutrons. Oxygen 16 is stable when it has 16 protons and 8 protons and 8 neutrons, so 16 in its mass number. Now, when it becomes unstable is when we start looking at isotopes. And isotopes are elements with different number of neutrons but the same amount of protons. If you change the proton of any element, you change it to a new element. So if you add a proton to helium, you will change that to lithium. Okay? But you can keep adding neutrons to helium and it will stay as helium, but it will be unstable. And what this graph is representing here is it's representing the relationship between how many neutrons you're adding to its protons and how it will decay. So I have here an NZ graph. N stands for neutrons and Z stands for protons. And what I've drawn a graph of N equals Z, so a lovely straight line where N equals Z. So the amount of neutrons is the amount of protons it has. So if it's got 6 protons, it will have 6 neutrons, much like carbon is. And if we plotted a line here, and then, so we've got the N equals Z, and then if I start drawing here, and this black line is the stable line. So these are the elements that you see on the periodic table. We notice that after approximately 20, which is calcium, that line starts to deviate. You start ending up elements with more neutrons than protons. And this is when decay can start to happen, because you've got this imbalance. And as the element, so here the element changes, but the amount of neutrons get bigger, we start having tendencies to atoms decaying. So this black line is this stable line. So this is the ones that you see on the periodic table. If I start having isotopes that had more neutrons for the amount of protons I had, so if I had this line here, but I added a couple more neutrons, I would end up above it. We start being in this region here. And this region is known, so this is where we've got too many neutrons, which means you have beta plus decay. Okay, so it's too many neutrons on this side. So we have anything with an isotope on this side of the line where it has too many neutrons, it will decay by beta plus decay. On this side of the line, I'm going to have it's beta minus decay. Okay, just to remind you, a neutron goes to a proton plus an electron plus an anti-electron neutrino. So it's beta minus decay. On this side, I have too many protons. So this is where I get beta plus decay. So a proton goes to a neutron plus a positron or a beta plus just an electron neutrino there. Okay. So if it's got too many neutrons, it is likely to decay by beta minus. If it's got too many protons, it's likely to decay by beta plus. This region at the top, where it's really heavy, it's got loads of neutrons and loads of protons, this is where you get alpha decay. This is where you lose the helium nucleus. This is because it's so large, it will decay via losing the protons and neutrons. Okay. Now, just get my grammar correct. Now this is important. You should be able to use this graph to be able to, not only should you be able to sketch it, but you should be able to, using some data, be able to evaluate if it's going to be beta minus decay, which is where it's got too many neutrons, or beta plus decay, where it's got too many protons, by which side it falls of the line. When drawing this in exam, you must have this n equals z line drawn, and you must have this area of 20 also drawn, because this is where it starts to deviate. This is where the elements start getting bigger. So instead of having you have double the amount, you got 8 protons, so you'd have 8 neutrons like you would in oxygen. You start having maybe 27 protons, but you would have like 30 neutrons, etc. Okay, so you wouldn't have the same amount of protons and neutrons, and this is at this 20. So an examiner is expecting to see this n equals z line. They're expecting to see this 20, and they're expecting to see that you draw this curve here for the stable elements here. Being able to understand beta minus is on this side and beta plus is on this side is what you may be assessed on an exam.